So I want to make a correction, a little correction for the solution that I went over last night in practice problem number 3. So when you have the objects moving on the inclined plane, you can choose one of the two choices here of choosing j hat to be up, like this is the direction of positive motion, or choose it down, and you can do whatever. The way I suggested to take it up is because I saw that the acceleration of the whole thing is going up, and I always prefer to keep my direction for positive motion along the direction of the acceleration so that I get a physically meaningful equation. But this will not affect 3, so the equation for 3, I picked j hat here. I can do this separate from that. So when I pick j hat with the direction of the acceleration here for the third object, I get forces helping the acceleration, gravity, minus the tension. Again, as the acceleration is ma, so this is fine. And the relationship between the two tensions from the free body diagram of the pulley here, that this tension has to cancel those two tensions because it's massless. This is fine regardless of the choice of j hat along the plane. What you need to do here is the following. If you picked j hat to be up, so this is your positive direction of motion, then your reference, your origin has to be down here. So that it matches that, okay, this here is the positive direction, here is my reference. So you cannot put your reference up here because if this is positive, then the origin is here. While if j hat is down, if you choose like your positive direction of motion as down, then that is your reference, so that this is the positive. So you need to be consistent about that. So let's see how we can get the constraint equations here. If the reference is like here, then this is what I'm labeling as x1, and this is what I'm labeling as x2, then xp, and also I have this is a fixed distance between the ground and the pulley, so I'm just gonna call it x, some like constant distance, this whole thing as some d. Okay, so this is my coordinate system now. The reference is here, positive direction of motion, x1, x2, xp, and d. So when you write down the length of the first string here, so to get the constraint, this part here between 1 and the pulley, this part is xp minus x1. See that xp minus x1 gives you this portion. And similarly here, xp minus x2 gives you that portion. And then plus the little pi r that we don't care about. So when we differentiate this twice to get the acceleration equations, you get 0 equals 2xp, 2ap minus a1 minus a2. So that's the constraint here. And I believe this is exactly the same constraint we got before, just with a minus sign all over, so it was the same. So no harm done so far. These equations are fine. But when you write down the second rope, so the second string here, this part of it is the fixed distance d minus xp. So this is xp, so d minus xp. Then plus what I defined here for the second part, this is the reference y3, so plus y3. So when I differentiate, I get minus ap plus a3 equals 0. So I believe here this is the sign that I missed last night, because that's when you do the reference in a consistent way with the direction of positive motion. So this is the correct constraint equation for that direction of motion, because the reference has to be there. And finally, the free body diagrams for one, for example, it will have mg sine theta and tension T1. And since I defined the direction of positive motion to be with the acceleration, then forces helping, that's T1, forces against the acceleration, that's m1g sine theta equals m1 a1. And similarly for the second one, T2 minus m2g sine theta equals m2a. So these are the 6 equations, 1, 2, 3, 4, 5, 6. 4 from the free body diagrams, 2 from the constraints, and you should solve them together. And the only point is that if I picked j hat positive up, then I put the origin down. If I picked j hat down, like the positive down, I put the reference here. So you can repeat the same problem, but with the reference here, like we did. But like j hat being that way will flip those two. Tension will be negative, mg sine theta will be positive, So this will be flipped, but the constraint equations also will have some flipping, but that's the consistent way of doing it. J hat is up, reference is down. If you chose J hat is down, put the reference up.